The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to the Aculon NANOPROOF Series PCB Waterproofing webinar. Thank you for joining us today. My name is Edward Hughes. I'm the CEO of Aculon, and I'm joined here with me today is Mario Gattuso, who is our Senior Product and Program Manager at Aculon. Today, in the next hour, we're going to be giving you an overview of Aculon, talking a little bit about our partnership with Henkel, talking about PCB waterproofing and an example of a market need, and then introducing the NANOPROOF product series, some application methodologies, giving you a competitive comparison against other technologies that are out there in the marketplace, some new testing, and some examples of case studies. In addition, we'll be taking Q&A. As you'll see in your screen, there is a Q&A box. Please feel free to type in questions. We'll try and take as many as we can at the end of the session. So please type in the questions and then we'll go through them afterwards. This webinar is going to be recorded, and you will be sent a link afterwards, which will give you a copy of the slides, as well as a link to the recording, so that you can basically watch this again at your leisure or forward that link on to a colleague if you feel it's appropriate. So let's start with who we are. Aculon is a leading provider of surface modification technologies. We like to think of ourselves as surface solution experts. What we do is we develop and produce technologies to modify a broad variety of surfaces, metals, glass, polymers. Obviously, when we're talking about PCBs, there's a number of different materials on a PCB. And our treatments can be hydrophobic, oleophobic, hydrophilic, adhesion promoting, and we do super hydrophobic as well. Our treatments tend to be very thin and easy to apply and need minimal capital equipment. Most of our applications, as you'll see, are spray or dispense or dip methodologies, particularly in this NANOPROOF series, and we avoid the more batch and costly equipment such as vacuum deposition processes. So we, as a company, we have three business units: electronics, where we're going to focus today, oil and gas, and a specialty business. So you're clear on what we do as a company. We are in the business of developing and producing chemistry. And so hopefully if some of this interests you, then some of you will want to try some of that chemistry for application, or alternatively send parts in for us to apply for you. Let's go back. Skip down. Okay. We're based here in San Diego, California. We have our technology center here where we do our applications and development work. And then we also provide central global logistics from here and ship to our partners either in Europe with a company called Caplink or into some of our distributors in Asia. And we handle directly the North American market ourselves. Some of you may be interested in the news we broke at the end of last year regarding a partnership with Henkel, and we've had a lot of questions about that, and so obviously it's appeared in a number of different publications. So we're delighted to be partnering with Henkel. For those of you who don't know, Henkel is a very large and successful German chemical company based in Germany, Düsseldorf. And they have a lot of different product businesses, including an adhesives business and some consumer product business. We're partnered with the Henkel Electronics, which is a division based in Irvine, California, and focused on specifically PCB waterproofing for some very high-end applications. Our relationship with Henkel is such that we'll provide the technology for the waterproofing as part of their overall waterproofing solution. So we provide liquid applied waterproof coatings. And they are going to focus on some of the very large mobile device manufacturers. And we have industrialized a product with them. And they're working on another product as well that to put into their range. So for those target accounts, if you are going to fall into a very large mobile device manufacturer, then what you'll find is that Henkel's going to be handling pretty much all the commercial aspects of this, including the application testing and support, the manufacturing, supply, invoicing, and QC. And Aculon's role is really for a technology provider. For companies that don't fall into this large mobile device manufacturing category, then you would be dealing directly with Aculon. So let's start with talking a bit about the need for PCB waterproofing. So it's an emerging market, it's an exciting market, it's growing very rapidly. You're starting to see a lot of premium devices have some kind of waterproofing capability in them already, whether it's a smartphone or a tablet or a wearable. We are seeing a lot of other applications, and whether it's automotive or whether it's things like desktops or laptops or IoT devices where people are looking for waterproofing. And what we're finding is the process that we are delivering to the marketplace, which is a solution-based process, is seeing some pretty rapid adoption in a number of these marketplaces. And it's partly because people are looking to avoid some of the hassles of the conformal coatings. So let's be clear on what we're trying to do here. And I'm going to talk a little about smartphones just as an example of this. It's obviously a very well studied part of this, but smartphone is obviously a huge marketplace. By 2020, 1.7 billion smartphones, with a $400 billion value. So one of the challenges is that smartphones, according to ADC, 900,000 of them a day are damaged by liquids. So that's obviously a huge problem. And if you look at basically when you think about what damages a mobile device, half of it's shattered screens. I'm sure we've all seen those. But the next biggest portion is some kind of water immersion or water contact. So in this chart, 35% of the damage basically comes from water basically getting onto the phone, getting into the phone, and it could be a splash or a spill. It could be a shallow immersion. In some cases, a deep immersion, such as dropping it in the pool or something like that. But it's a very substantial damage. So let me switch and show you a little bit of a fun video. It was St. Paddy's Day last weekend, and this is a video that we put out that is kind of a fun thing to show. I need you to waterproof my phone. Okay. Brilliant! Brilliant! So that was a kind of fun video we did for St. Patrick's Day, and that phone was obviously waterproofed and then immersed into Guinness for 30 minutes, and obviously, as you can see, it's still functioning at the end of it. So that's kind of a little bit of a humorous thing, but obviously in real life there are many different causes of damage. Whether it's dropping in the pool or a toilet or just being exposed to outdoor environments, rain and humidity. We're seeing lots of different applications. We're seeing it in industrial applications. We're seeing it in automotive requirements, medical device requirements for splashing in the operating room. So a lot of people come to us and say that they want to have their phone or their device, their particular application, waterproofed. So one of the things we always like to ask them is, well, what do you mean by waterproofing? Because there are various levels of waterproofing, and this chart here basically gives the IPX scale. So we can help to define what they're trying to prevent. So if you're looking at splashing water from any angle, then that may be an IPX level 4. If you're looking for, like the mobile device guys, often it's IPX7 or 8, where they're looking for a water immersion for 30 minutes at a depth of up to 1 meter. So lots of different angles. So we do things on video doorbells, etc., where you're looking at potentially, the device getting wet from a rainstorm or from an irrigation system. So we like to try to understand what it is that the customer's looking for, because in many cases we've worked with these different components, and so we help to define waterproofing based on this. And this is a chart that we've put together for what we see is really often what people are looking for. A lot of people are looking for protection against splashing water. And so you can see a number of different applications here. Some want to have protections against high pressure water jets. And again, so outdoor telecommunications boxes, these type of things, outdoor lighting. And others are looking for lower levels of protection, such as hearing aids, where they want to have spraying water on this stuff. So we've designed a series of products that have different levels of protection. So it's not one size fits all, but rather you have the opportunity to select which product makes the most sense for your specific application. With that, let me turn this over to Mario, and Mario can take you through more about the product and some of the features and the application methodologies.
Great. Thank you, Edward, for that excellent introduction. So we're going to get into the NANOPROOF series of products, and we're going to talk about the features, the technical performance, and we're also going to get into some case studies as well. So to introduce the NANOPROOF series, the NANOPROOF series is a liquid phase product line of treatments that utilizes proprietary technology, surpasses the performance of most all competitive coatings, utilizes readily available and affordable application equipment. In fact, many of you might have the exact same equipment that is utilized to apply these materials already. Some of the many benefits of utilizing these products is you're certain to reduce product returns due to water damage. You're going to improve your yields as rework is possible after coating. If you're looking at an alternative, most traditional conformal coatings or vacuum deposition treatments cannot be reworked easily, and so if there's a failed part, it needs to be disposed of. There's no masking required for the NANOPROOF products, so masking, the cost and time of masking is eliminated. These coatings are all safe, non-toxic, and can be used in any factory environment. In addition, they're incredibly affordable. When you look at it on a per unit basis, they're very easily implemented from an economic standpoint. So here is a summary of the main NANOPROOF product lines. So there's obviously a bunch of information here. We won't get into every detail, but what's important to note is that we have products that are geared towards lower levels of protection, IPX3, all the way up to IPX7, IPX8, very robust levels of protection. So depending on your application's performance needs, your cost requirements, your application method desired, thickness requirements, whether you need the treatment to be flexible. We have a range of products that can meet almost any need. So we have, from the most robust materials possible to extremely easy to apply spray applied coatings that are going to get you pretty significant protection versus no coating. All of these treatments come standard with a UV dye for your automated inspection equipment or manual inspection equipment. They can also be supplied without a dye if you desire. These treatments are designed to be incredibly thin in many cases. For the treatments that are very thin, in many cases you can coat over all the components. That includes antennas, headphones, buttons, speakers even. With our thicker materials, you've got to take it on a case-by-case basis, as there will be an impact when you're putting down a treatment in the 30 to 40 micron thick range. But it offers a lot of flexibility in terms of just being able to either coat everything, or if you can't coat everything and you don't want to mask, well, then you can use selective deposition. We recently launched a new white paper that's studying the waterproofing performance of our 7 and 8 series products. So that white paper is available for download on our website currently, and we're also going to send out links for downloading and viewing that white paper. But I also wanted to summarize some of the testing that was seen in that white paper for you as well. So the start of the white paper, I'm sure many of you are familiar with the IPC multi-purpose test board. Starts off with the multi-purpose test board. We're evaluating two of our more robust treatments, 7 and 8.4. Those treatments are really designed for pretty aggressive immersion environments. So these boards were treated and then dipped for 60 minutes, wall powered at 18 and then 50 volts into salt water. Leakage current was measured every two seconds so that we could detect any current spikes utilizing a picoammeter, a very sensitive voltmeter. Here's an example of a control coupon. So before immersion, it looks great, and then after immersion, you can see there's extensive corrosion. It's essentially a failed part, and the current leakage is incredible from the get-go, and the current leakage actually falls off because the part is failing, and so less current is flowing because the part has become so corroded, which is as we would expect. Now, here's an example of after 18 volts in salt water for 60 minutes, NANOPROOF-7 before and after test. There's no observed corrosion, and you can see the data. There's three data sets here. They all fall well below the 500 nanoamp threshold. And then 8.4, again, there's no observed corrosion. There is, you may observe in the picture that there's some markings at the top. That's just a blemish on the part. That's not where you would actually see the corrosion taking place. And again, the 8.4 is well below the 500 nanoamp spike threshold. You can see there's one part that had a rise up to 200 nanoamps of current, and then another that had measured a slow approach to almost 200 nanoamps as well. But all three test boards well below the 500 nanoamp failure threshold. And then here, I'm not going to get into these numbers. This is more just for your viewing. When you do download the paper, we have the data on the average current, max current, and then average resistance of all of these tests in comparison to a control board. So we figured we'd step it up a little bit and run a test at 50 volts. This is both 7, the 8 series material, and then we also threw two conformal coatings, an acrylic-based and a polyurethane-based conformal coating into the mix. And as you can see, both the 7 and 8.4 fell well below the 500 nanoamp threshold at 50 volts. But these two conformal coatings, the acrylic and the polyurethane, which we know from experience on customer parts, don't pass immersion testing, both appeared to pass this test as well. So they're both below the 500 nanoamp threshold. There's some spiking up to 300-400 nanoamps, but they still are considered a pass. So that tells us that, we know from in practice that the traditional conformal coatings aren't getting to IPX7 or IPX8 levels of immersion performance. So there needs to be a better proxy for evaluating how well these coatings do in a real-world scenario where you're actually coating a three-dimensional component. So in order to do that, we utilize some very simple LED test strips, which are composed of LEDs and resistors, which have three-dimensional shape. So this does evaluate the ability of the treatment to conform to the shape of the component and provide protection even on the edges. So we coated the LEDs, and these were immersed in the same saltwater mix for 60 minutes, powered at 12 volts, just because that's the inherent design of the strips. And afterwards, they were evaluated for corrosion and functionality. You can see here a treated an uncoated part. Looks great. Before, afterwards is failed. The lights aren't working, and there's just massive corrosion on every single resistor. Just across the board failures on these LED test strips. So now let's get into the conformal coatings that on the IPC test board passed. So now you start to see some differentiation. They pass the IPC test board, but they fail on the LED strip. These were actually applied at nearly 100 microns in thickness, but these coatings, when you apply them, they simply flow off the edges of the parts. So unless you're applying so much material that you essentially flood all the components above the top level, you're not getting a coating on the sharp angles. And as you can see, the resistor fails at the edges and you have a failed part. So you're not really getting immersion protection. Again, this is a repeat of the acrylic part. The exact same thing happened with the acrylic part. It didn't coat the sharp angles, and after immersion, there was a significant failure. And now, to compare to the NANOPROOF-7 series, which passed the IPC board testing of both 18 and 50 volts, it also passes the LED strip. So the NANOPROOF line of materials is designed to actually coat the edges of the part so that you get not only good performance on the IPC test boards, but also in real-world scenarios when you have three-dimensional components which need protection. Again, a repeat of this with the 8.4. So now we're going to get into some independent NPL testing that was recently done at the end of last year. They did a study, again, this is on the IPC multi-purpose test boards, so a study on flat boards to evaluate the performance of conformal coatings, and they also included several of the NANOPROOF products. And they compared the performance of these coatings as well with the waterproof protection ability of having a hydrophobic coating. And they essentially confirmed our findings, was that having a insulating layer, which is what the NANOPROOF series provides, is the most important aspect for providing water protection. That simply having a repellent surface doesn't necessarily protect from current leakage. Because they didn't coat three-dimensional parts, they didn't show any difference between the NANOPROOF and the conformal coatings that they tested, which mirrors our study results as well. And they're now in 2019 in progress testing on 3D surfaces. So we're excited to share the results of that. Now, there's another video that we created that I wanted to share with you. This video, just a moment while I pull it up, is a video of NANOPROOF coated phone operating in a fish tank for 30 minutes. It's just a fun video that we thought we would share. Apologies for the delay getting it started right now. Okay, so now we're going to get into some of the application methods for applying NANOPROOF. As you're aware at this point, NANOPROOF is a liquid applied coating. We don't use vacuum deposition chambers. So because it's a liquid, it's very flexible in its application process. Now, some of these options may differ between different products depending on their viscosity and other characteristics, but in general, there's many methods for applying these materials. The most common of which are spray, dispense, jetting, and then also dipping in some cases. These can be applied in small batches or using manual techniques. We have some customers who coat by hand, and then they can also be implemented inline on more robust pieces of equipment from PVA or Nordson to Simtech for high volume applications as well. Now to get into comparisons to some of the other water protecting options that are out there, we're going to compare NANOPROOF to gasketing and vacuum deposition. So gasketing, usually utilizing O-rings or form-in-place gaskets, offers really effective initial performance, in many cases IPX5 and above. Several companies have achieved IPX7 using this route, but it is quite complicated. It uses valuable real estate in the device. It can require port plugs for any access points. It's not cheap, and then most importantly, it's prone to catastrophic failure. So while these parts will perform great initially, if they're exposed to any sort of abuse and those gaskets fail or have some sort of leak, then water is able to just rush right in, and there will be no protection. So what we're finding is that people are either looking to eliminate gasketing and look for a different option, or in some cases, customers who are gasketing already and don't want to move away from it are looking for a cheap and simple route to add a second level of protection inside and on the boards, which we can certainly do without having to change any of the gasketing features already there. But because it is prone to catastrophic failure and the cost, we feel it's not a good long-term solution. Then vacuum deposition, Paraline, and other methods have been around a long time, but they don't really get to high levels of performance without extremely long deposition time. So in general, they're only going to get you to IPX2, 5 levels of performance, and even then, they're very complicated. There's masking and demasking steps. The capital equipment for vacuum deposition is incredibly expensive, and then the batch processing is just inherently slow. So the next generation option, or the NANOPROOF Extreme line of coatings, is going to get you IPX7, even IPX8 levels of performance. It's easy to apply. It'll cover complex features, and it's cost effective. The material cost in most cases is less than $1 for even large parts. The only downside considerations are some of these materials do contain solvents, but we also have solvent-free variants. And for certain applications, the process optimization can be somewhat intensive. But once the process is optimized, it's usually still a very simple process. So here, and this is more for your viewing after the webinar, I'm not going to go through all of it. We do have a technology comparison comparing gasketing, vapor deposition, and the NANOPROOF series of material. Just a reminder that NANOPROOF is going to get you to above IPX7 levels of performance if you need. It's affordable, easy to apply. It's a very robust solution and a better long-term solution than gasketing, which is prone to failure, expensive, and certainly a better option than vapor deposition, which is just inherently slow and tedious and expensive. So now we're going to touch on a few case studies of programs that we've successfully implemented. So we had a customer producing Bluetooth headsets, and they approached us for support protecting their part from sweat and splashing water. They didn't necessarily need full immersion proofing, just IPX3 and IPX4 if we could get them there. We ran through a few rounds of iterations, treating customer parts, and also did some evaluations at the customer site to evaluate the final process. This took around 6 months worth of time, and we ended up working with NANOPROOF 4.0, which is a easy to apply, spray applied material, and the customer utilizes this on their parts and achieves IPX4 levels of protection. Next device we're going to talk about is a wearable device that we treat for a customer. They're looking for sweat and splashing water protection. Didn't need full immersion proofing. They just needed to protect from rain and shower. They were looking for IPX4 levels of protection with IPX5 as a desirable target. Aculon initially treated several parts via spray, and the customer identified a few high voltage components which needed additional protection. So from there we added some spot treatment of our more robust material, NANOPROOF 8.4, and ended up with a dual stage solution where we spray with 4.0 and spot apply 8.4 on sensitive areas, and got to IPX5 levels of protection for this customer. The next case is a customer with a outdoor home electronic device, essentially an outdoor Internet of Things. Was looking for protection from splashing rain and irrigation equipment, but they didn't need full immersion proofing. They were looking for IPX5 and, if possible, IPX6 levels of performance. So we worked directly with them to identify that NANOPROOF 5.1 would get them to their IPX5 level of performance with a very simple application method. They wanted to avoid all masking, so we actually coat the electrical connections and then use a diluent solvent to connect the connector after the coating has been applied and dried. Another great application for us has been treating hearing aids. We actually have a few customers on this exact same application. Looking for protection from sweat and splashing water, usually not full immersion, and IPX3, if possible, IPX4 levels of protection. This is a very simple qualification process. It didn't take much time at all. The customer obtained and tested a few of our samples and selected NANOPROOF 4.0 and treats all the parts internally except for the speaker. And it achieves IPX4 level of performance for them. The next case is cell phones. As you know, every single cell phone company is looking to provide a waterproof device. And so we've been directly collaborating with several manufacturers towards success of achieving IPX7 on cell phones. Some of these cases would be to provide the sole waterproofing barrier, and then some are also as secondary backups to existing gasketing. These are fairly long qualification processes, in some cases taking 12 to 24 months. And we're working with NANOPROOF 7 and 8.4, utilizing a variety of application methods. So to summarize, the NANOPROOF waterproofing option offers high performance, the ability to achieve IPX7 and even greater, continuous production, there's no batch production required, fast cycle times, there's no cure cycle and no masking, the ability to allow you to make connection post-treatment, and which eliminates the need for masking and demasking. And the ability to rework. So this is huge for some people. The treatment can easily be removed with a diluent solvent, so you could rework any part of the board. In most cases, traditional coatings such as conformals or CVD cannot be reworked and need to be scraped off. So now we'll talk about how we can move forward if you're interested. And so what we like to do is we would like to work directly with you to help identify the best option for success. And so there's a few approaches to this. The simplest of approaches, and the one we usually like to avoid the most, is doing a customer trial where we sample some products it's really better, if possible, if we're able to get your parts and evaluate your parts and look at which solutions are really going to fit best. We can get your parts, provide treated parts back to you, in addition to mailing some samples. And then even better if we can get our technical teams on the same page and set up a DOE of some sort to look at a route forward to optimizing a solution custom to your parts is really the best option, and we can do a round of testing at our facility for you and iterate as needed to optimize the process for you. So in summary, Aculon is the leading supplier of nanoscale repellency technology. NANOPROOF is already qualified in production on several applications. It's easy to apply and cost effective. We have a variety of options based on your performance requirements and are proven to outperform the competitive technology and have the ability to supply NANOPROOF globally, whether it's Asia, the Americas, or Europe. So with that, I encourage you to enter questions into the toolbox. I'm going to be doing a Q&A session here. So I'm going to see what questions we've gathered up, and I'll be answering them. And as a reminder, we will be emailing every single one of you, and you're going to get a link to the slide deck here, and you're also going to get a link to the video recording of this webinar. So let's see what questions we have. Okay. Okay, first question is an excellent question. Are there companies in southern China that offer your coating on a contract basis, or do I need to install capital equipment in my EMS provider's factory and have them manage the process? So as you type this in, we're actually in the process of looking for companies that would be willing to apply this in China on a contract basis. So we hope to have a list for you shortly. Until then, the EMS provider, in many cases, probably already has the equipment for applying conformal coatings. These are very simple PVA or Nordson Asimtech spray machines typically, but we'll get in touch with you and we'll see how we can best help and see if we can connect you with a contractor that can coat your parts for you without having to invest in capital equipment if you would like to avoid that. Next question is, what is the thermal stability? How high of a temperature can a NANOPROOF coating survive? That's a great question. So that depends on which NANOPROOF coating, but in general, the NANOPROOF coatings are all stable to about 200 to 300 degrees Celsius. So we have coatings that can survive high temperature reflow, and we also have coatings that can survive low temperature reflow. But in all cases, they're temperature stable to around 200 Celsius at a minimum. Next question is, will the coating adhere to a PTFE surface without a surface treatment? As long as the PTFE is clean, it will likely adhere. The adhesion is more than likely not going to be as good as it would be to another surface. But because these coatings are intended to be applied internally on a device, we found in most cases the adhesion is not terribly critical. So as far as applying to a PTFE part, that would be, I think it would depend on the component and what sort of performance requirements you're looking for. So we'll get in touch with you on that and see how we can best help. Next question is, have we done any biocompatibility testing on your solutions? So yes, some of these coatings have been through compatibility screening and some have not. So let's talk about your specific application and have a look at which coating would be most applicable to what you're trying to do and see if it's a good fit. But even for the ones that haven't been through screening, we expect that all of our coatings would be biocompatible. Next question is, do you have a chemical resistance matrix? So yeah, so if you go to our website and look at the NANOPROOF page, so we'll forward that link out as well to all of the viewers here. There is a description of the chemical compatibility of each of the NANOPROOF coatings. So in general, you'll find that the fluorinated coatings are compatible with nearly all chemicals except fluorosolvents, which, truth be told, aren't really run into all that often. And the hydrocarbon-based coatings, your 1.0, 2, 4, and 8.4, are resistant to aqueous solutions and some organic compounds, but they are also can be dissolved by some organic compounds. And depending on which coating, there would be a different list for each. Next question is, what are the temperature limits for the product? And so that kind of gets into what we talked about a moment ago. The coatings are all stable to 200 to 300 Celsius in general. And then the other question is, can the product be used to make something autoclave resistant? So you can coat these parts and put them through autoclave, and it is not expected to damage the coating. I don't know if it's going to make the part autoclave resistant. I'm not sure what the goal you're trying to achieve is. So maybe if you can elaborate, we can advise a bit better. Another temperature about max operating. We've already answered. Next question is about humidity. How does this stand up to high heat and high humidity, 85 C, 90 relative humidity? So these are stable in humidity and at temperature. So we do MIR testing on all of these parts as well, which involves soaking in 85 and then evaluating the performance for failures, and they all hold up just fine. Next question is, no masking is required was stated, but then how do you selectively avoid some parts, like speakers? That's very simple. If you're looking to selectively coat a board without coating certain parts, then you would use a selective deposition piece of equipment. Those are available from PVA or Nordson Simtech. There's robust pieces of equipment with all the bells and whistles, but there's also very, very affordable options coming out that are fairly simple and not too expensive, and you would basically design the sequence so that it only coats the parts of your board that need protection and avoids speakers and other areas that would have ill effects from the coating. Next question is it affordable for big products such as an electronic ballast? And that's a great question. So these treatments are extremely affordable. They depending on which material is selected, a little bit goes a very long way. So for the person inquiring about electronic ballast, if you can send me some idea on surface area of the parts, we can get you some ideas on potential costs to coat for each of the various options. Let's see. Next question. For removing the coating, is it a chemical or abrasive contact? So you can go either way. You can, in some cases, you can probe through the coating. Each of these coatings will have a compatible diluent solvent that will remove the coating if you want to strip the board or remove the treatment from a section. And then you could also try abrading the material off of the board as well. Let's see. Next question's a long one. So we have a current user using NANOPROOF 1.0 on the product, and they're looking to increase the level of protection to IPX7 with a sprayable coating. And they're wondering if the assembler will need new equipment. So that's a great and relevant question, because we're actually in the process of launching a coating that will achieve IPX7 and be sprayable. We would need to find out what equipment they're currently using in order to advise whether they would need new equipment. It's possible they could use the same thing, and in an ideal situation, maybe only swap out a valve. But we'll reach out and talk to you about that more directly. Next question is, how is reworking possible? Is a solvent used? Yes, so the answer to that is yes. The solvent is used to remove the coating, and then you can rework the part. Okay. A few more questions. Another good question, is the coating compatible with a no-clean solder paste residue? So we do recommend that you are applying the coating to a clean board, and that includes removal of no-clean solder paste. So it's not imperative that the board is clean to a molecular level, so it's not necessary to do plasma treatment, but we do recommend that all contaminants are removed off the board. So we do have test data showing that treated boards with and without no clean solder on the board do behave drastically differently from a performance perspective. So if you can clean the boards first from their no clean flux, we do recommend that. Next question is, do you have experience with overmolding a nano-coated PCB with a hot melt material such as Henkel Technomelt? That's not something we've looked at directly, but I see no reason why you wouldn't necessarily be able to apply a hot melt over the NANOPROOF products. If for your product performance that's needed for some reason, I think it's something you could evaluate, but it's not something we've looked at this time. Next question is this presentation available to download? And yes, it will be. As soon as it's over, we'll be mailing out an email with links for downloading the slides and also for downloading the video. Next question is, what is the flammability rating? And these coatings after application, so after the solvent has flashed off, are all non-flammable. Next question is somebody wondering if it'll adhere to PET, and yes, it'll absolutely adhere to PET. These materials are designed to be substrate agnostic. They'll apply to pretty much any material so any substrate material, whether it's plastic or metal or glass, it can be applied. Next question is, will it hold up to an ultrasonic bath using an enzymatic cleaner? That's not something we've looked at. It sounds like a pretty unique application. I think the initial thought would be that it would, but if you can send us an SDS or a data sheet of your cleaner, we can evaluate it and advise which of the NANOPROOF materials would probably be the best fit for that application. Next response is, cleaning no clean residue will probably not work as our supplier does not have the cleaning equipment in-house. Can I still implement? So yes, you can absolutely still implement the NANOPROOF over your no clean residue. It's just not going to perform as well as you would expect it to perform if the board was properly cleaned. But you're definitely going to get far better performance than if your board was not coated. So I do want to emphasize that if you can't clean your boards of their no clean flux residue, you're still better off coating. But if you can clean the boards, we've documented that it will make a performance difference. And then looks like the final question is, are these materials RoHS and REACH compatible? And the answer is yes. Across the board, all of these materials are RoHS and REACH compatible. So that looks like the last of the questions. So that's some excellent interaction, some great questions. Several of you had questions that I really can't address in the amount of time we had here, and I'd like to get a lot more information about your application. So we'll be emailing you afterwards, and so please, let's talk about your applications, and we'll see how we can best help you implement your waterproofing find a solution to your waterproofing needs. So with that, thank you very much.
Great job, Mario. Thanks for doing that. It's a great webinar and lots of good questions, as you said. So you'll be getting a link or an email with all the different links for the presentation and the video, etc., and obviously Mario's contact information. So we look forward to working with you. Thank you for taking the time today to listen to this webinar, and we hope to be able to help you waterproof your components or your devices. And with that, we'll be signing off. Thank you.
Thank you.